So this is a numerical, the truss supported and loaded as shown in figure. Determine the force in the member BC, CD using section method. So whenever if they asked to find out force in particular member BC, C and D, at that time we are expected to solve it by method of section. So let us see the members. This is your member CD. Then this is CE and one C. BC is here this member, this vertical member. Now, okay, this is the concept of method of section. In method of section, select such a section which cuts maximum 3 unknown forces. Now see here in this particular, if I want to cut all these 3, means this one and this one. So we have concept that whenever we take the section at that time, it cuts the entire truss into 2 parts. So here you can take the section like this, 1, 1, clear? And if you take the section like this one, I will take the section on another figure here. See, if I take the section like this one, so here unknown 1, unknown 2, unknown 3 and unknown force. There are 4 forces which are cut in the section. So this is a section which cut your 4 member. This is member F, BC. This is F, CE. This is F, CB, and this one is F, A, B. Clear? So what is the concept over here? We can't take a section which cut the 4 unknown. So here all these 4 are unknown. So we have to take the first section like this one. This is one force which is force CD. This is another force, that is force CE, and one more force which is cut in section 1, that is force B, which is not a requirement of your numerical. Clear? So if I draw the FBD of this section, now this is my section 1, which cuts force CD, another force that is CE, and one more force that is FBE. Clear? So these are the 3 forces, and the portion which are beyond the section, we'll just draw that line as a dotted line, and your truss is like this. Here there is a force of 3 kilonewton. Here there is a force of 6 kilonewton. Clear? Now in this method, we have to take only moment. In method of section, we take moments at various joints. Now, we have to find out force in this member CD. So you can say that if you want to find out force in this member CD, so you can take the moment from point, this is your E. Why I'm taking moment from point E? Because here this force CE and PE both will be passes through the point E, so that the moment of these 2 unknown forces will be 0. Clear? The blue color force moment will be 0 if you take the moment about point E. Taking moment about E is equal to 0 condition of equilibrium. Your force, this one FDE, whose perpendicular distance from this is 1.2 meter and it will rotate anti-clockwise. So minus FCD into 1.2 is your first moment. Clear? Now second force, this is 6 kilonewton, whose perpendicular distance from this point is how much? This distance between these two forces is 1.2. Again, it is clockwise. So 6 into 1.2. And then next force is 3 kilonewton and moment of that force from E. So again, it is clockwise plus 3 into 2.4 is equal to 0. From this, you will get a value of FCT. How much it is? Is that 12? Check your this one. This is your another force FC. To find out the force in this member, you can take the moment about this point B. If you take moment about B is equal to 0 clockwise positive, you can see that you can resolve these forces. You can resolve these forces to component. And if you take the moment about B point, this 6 kilonewton force will be passing through the same point, and the vertical component of this inclined force will be passing through the same point. Now you have to take the moment of this horizontal force, FCD into 1.2, and that is minus anti-clockwise. Even though this horizontal component of inclined force minus FCE cos of 45 degree is the component into perpendicular distance 1.2. Clear? The component inclined force resolved into two components is horizontal force plus perpendicular distance 1.2. Now after this 3 kilonewton is clockwise plus 3 into 1.2 from with respect to B. We are taking moment about B point, so this 3 into 1.2. Clear? So now from this one, the value of FCD is minus 12 into 1.2 minus FCE cos of 45 into 1.2 plus 3 into 1.2 is equal to 0. I will divide the whole equation by 1.2. Now, what we'll get over here? This is minus 12 plus 3 is equal to minus 9. So FCE on that side is equal to minus 9 upon cos 45 degree. Is that minus 12.73? Clear? So by method of joint or method of section, we'll get the same answer. So out of these three, we have calculated. CD and CE. Now BC is unknown. Now we have to calculate BC. So you can say that by zero force principle, FBC is equal to 0. So there is no need to apply the second section. Clear?